Hello, hi guys. Today I'm going to explain about the cloud computing. What is a cloud computing? What is a cloud computing and what is the exact definitions and what are the models of the cloud? Models is nothing but like infrastructure, platform and software. Okay, and next how it is constructed, how the cloud is constructed and how the cloud virtualization is. Here virtualization is very important. It is a key for the cloud. Okay, and how cloud data is stored and different technologies stored for the cloud. Here is the exact definition for the cloud. Before going to the cloud computing, it is very difficult to determine as there are many definitions. There is no single definition that encompasses all aspects of the cloud. It's very difficult to pin down as well. So now I'm going to use the NIST definition of the cloud computing. And one of the majority which is used today and cloud computing is a model of enabling convenient on-demand network access to a shared pool of configurable computing resources. For example, networks, servers, storage, applications and services that can be rapidly provisioned and released with a minimal management effort or service provider interaction. This definition I have taken from the Rotten John like cloud computing, which is explained by the implementation handbook for enterprises. Kindle location 1000 recursive for us. You can search for this. Taking this as one definition doesn't mean until we start to break down it. Now I'm going to break down the cloud definition. For example, just can see in the definition what is a convenient, what is on demand, what is a network access, shared pool. Convenient. What is a convenient? It is easy access to the resources. Very little setup is used here and little setup costs as well. On demand. It is available and ready to use as required. And shared pool. You do not have the exclusive access to the resources and you will share with other applications and the users. Configurable computing resources. What type of the resources you're looking for? Configurable computing resources. What type of resources you're looking for? For example, you do not have an exclusive. You cannot determine and choose what resources you will use in your applications of the cloud and rapidly provision and released. Here, if your application needs to scale up or scale down, then your application has easy access to extra resources and can add them to the application easily. Just like release of the resources are just use of ease. The cloud computing is a general for the daily life. In the daily life, what you are using, just like water, electricity and the gas, these resources are on demand. You can use as much as a little as you like, but for this in the daily life you're paying for the resources what you're going to use. But in the cloud computing you need to pay for the CPU usage, input output usage, storage usage, and more as you pay for the resources, more you have to pay the money. And cloud history. Early computers, ENIAC-1, etc. were extremely bulky. Some took for the few football fields in area and weren't very powerful compared today. Used values, single purpose missions, and later versions were general purpose. Users had to submit their programs to operators who would run them and give back printed results. And later versions of these computers got more powerful and became network. For example, mainframe type systems. Users could share a single mainframe by using a dumb terminal, and the mainframe would schedule the many jobs in order to give the users a response in a quick time. In 1990s, for example, before entering to the worldwide, okay, www dot, okay, advert of IBM computers in the early 80s got rid of mainframe in the following years. Everyone has a desktop machine with all the power that has needed. There we don't need any mainframe. Single desktop model was ideal at that time. In 1990s, the advent of the World Wide Web and the distributed systems. Here, we now have the idea of the distributing computation among the multiple machines, moving resources and information to different places but accessible anywhere on the internet. For example, parallel computation. Nowadays, parallel computation became very popular. High barriers of entry to hosting sites on the web. This brings us up to 2000 and onwards. In the middle of this decade, when cloud computing became popular, however, it took many advances in different areas for it to work. It is not a single revolutionary concept. It is not a single revolutionary concept. Here, virtualization is a key for the concept. For example, just creating the machines with the settings that can be migrated anywhere in the cloud. If an instance fails, create a new one. If more power is needed by any application, then just add some instances. Before entering into the Amazon, I'm going to discuss about what is the distributed systems and distributed algorithm design. Distributed systems. A few points to discuss about the distributed systems. Multiple machines need to coordinate here, and failures need to be detected and handled, and system should look like a single unit. Distribution hidden from the user, and efficient workload and communication division. And algorithm design. Distribution of computations, distribution of data, synchronization, failure handling. Taking all of these small advances together has let the cloud computing become popular in the mid-2000s. One of the best examples is the Amazon. Amazon was amongst the first to popularize it. Amazon has a rather large problem with its web infrastructure. Here we are going to discuss about the two things. One is Amazon created a cloud system called EC2. This was run on the top of all the web infrastructure. Amazon rewrote their web stores to run on the EC2. This all runs on the EC2. Here we have to discuss about the two things. One is cloud scale up and scale down the stored resources as necessary, and they could rent out the spare capacity to others in the non-peak times. Since and later on, all the companies or startups have tried to take advantage of the cloud, and it's gaining popularity. For example, Google, Microsoft, IBM have their own cloud offerings at this stage. Some enterprises are switching their infrastructure to a private cloud for better use of resources. There are companies out there to run their entire business on the cloud. And next is Netflix. Nowadays, everyone is using the Netflix to watch the movies and daily serials with a high definition. Netflix is in 2013 according to the accounts of 33% of the used internet traffic, and it runs entirely on Amazon EC2. Uses about 20,000 instances of the to serve the media. And next is Google. Nowadays everyone is using the Google search, Gmail, Gmaps, Google Maps and other services runs on the Google Cloud. Outside users can take this advantage of that infrastructure to run their web apps. And next, taking an example of Sony computers. Sony Computer Entertainment. Kakai was acquired in SCEE in 2012 for approximately $400 million. Sony will use this cloud service. Sony will use this cloud service to render and stream previous console generation games, for example like PS2, PS3 and PS4, as they are not background compatible. Microsoft Gaming Division and Xbox. The Xbox One will offload some graphics AI computation to the cloud if it is available. Users Microsoft own cloud infrastructure. Sorry, I forgot to write here about the Microsoft gaming division, for example Xbox One. Okay, and here application should be parallelized. Before entering to the parallelizable for the cloud, as a network system administrator, what do you feel? I feel it has entirely new way of setting up your network and services, and not really the interesting here. And what do you feel as a developer? As a developer, an entirely new model of computation, one that has many consequences for you. We will discuss this in a bit later. Okay, every action and every application takes will have the monetary cost. More actions is more costly to you as a developer. Some cloud services will offer you a free quota to start. If you reach quota, your application will stop receiving the requests, or you can pay for the extra resources depending upon you. How much you're gonna use, how much you want to use in the limited way. Your applications must be parallelizable. Here is the condition, like application must be always parallelizable. For example, the trend in processing the power has been to distribute the work among its multiple cores and multiple CPUs. Processor speeds have not increased as rapidly over the last 5 to 10 years. You need to be able to break up your workloads into the distinct units that do not require results from other units. Your applications must be efficient. For example, every unit of the CPU time, input output, storage is going to cost you money. Remember, you need to pay what you are using. Smaller usage, smaller bill. You should try to use some more efficient algorithms and storage mechanisms if available and if possible as well. And next, third one is your application should be secure. Security is very important in the cloud. And the next when I'm going to discuss about how the cloud security is working and cloud virtualization, I'll discuss later how the security works as well. Okay, here's as simple as I'm going to discuss. Okay, in the public cloud, your applications will share the space with some other companies and vendors. You will need to encrypt your data in these cases where other applications spill over into your data areas. For example, cloud malware will try to do this. You also need to ensure that users cannot see each other's data. This is very important. Okay, data protection is extremely important in such a public environment. And next chapter I'm going to discuss about how the cloud virtualization works and how security works and how cloud storage is working and some techniques and how to install the Google App Engine and some problems I'm going to discuss about the Google App Engine. Thank you very much. If you like this video, please leave any comment or like the video or subscribe the video, please. Thank you very much.